So in this part of the video, I'm going to explain the negative acceleration, deceleration, which is also known as deceleration or retardation, and the distance time and speed time graphs. So I'll start with the negative acceleration. I hope you have subscribed to my YouTube channel. It's Physics with Cyrus Ishaq, and press the bell icon to get notified whenever a new video is uploaded. Share and subscribe. So let's talk about negative acceleration. Let's talk about the negative acceleration. The negative acceleration is given by negative acceleration this implies is that when the object is having a decrease in its velocity, the velocity is decreasing, right? In this case, the velocity is going to decrease. In non-uniform acceleration, the velocity is going to increase, but it can be decreasing acceleration or it can be increasing acceleration. But the negative acceleration signifies that the velocity is going to decrease. So let's say you have this is an object, let's say this is a car, and it was going at the velocity of, let's say, 50 meters per second, and it moved a certain distance and it came to rest, right? So the final speed was, I'll call this V initial or U. Let me do it with this. Let me write it with the same notation, right? Let's call this velocity U, that is the initial velocity, right? And the final velocity as 0 since it came to rest. And the time interval, I'm making the small change, this small triangle. This is a very fancy mathematical figure. This means the change in time, right? The change in time, delta t. This delta t, let's say, is let's say it's 10 seconds, right? So the acceleration in this case, that is, I'm going to calculate here, is the final velocity minus initial velocity over delta t. This delta t is the change in time interval. So the final velocity here is 0. The initial velocity was 50 and the change in time interval was 10. So the answer is minus 5 meter per second square. Minus 5 meter per second square. So you see the difference? Now the acceleration is negative. Acceleration is negative. So negative acceleration here is minus 5 meter per second square. If I'm going to write deceleration, I'll only state 5 meter per second square because the word D already signifies that minus is already there. So deceleration or retardation here is 5. Deceleration or retardation is 5 meters per second square. So what it actually means, it means that the car is reducing its speed at the rate of 5 meter per second every second. It is reducing its speed at the rate of 5 meter per second every second. So this is the concept of negative acceleration, deceleration or retardation. You see, with deceleration or retardation, you do not write the minus sign because the word D here, D, it already signifies that something negative is involved, right? Moving ahead, let's talk about the distance time graphs and the speed time graphs. In O-level physics 50-54 syllabus, it's clearly written distance time graph and speed time graph, right? So let me first tell you about the distance time graph. Distance time graph. Let's say an object is traveling from one point to another, and this is the distance in meters, and this is the time in seconds. The time is on the x-axis and distance is on the y-axis. Let's say it started from rest, it moved like this, then it moved like this, then it moved like this and like this, right? Something like this. And then there was this constant change. Remember that if an object is moving like this, you see that the rate of change of distance is constant. This is a constant gradient. What is gradient? Gradient is change in y coordinate over change in x coordinate. That is, here the y coordinate here is represented by the distance. So change in y coordinate is the change in distance, right? That is delta d, right? Delta d, and this time is delta t. And you know that if it is moving in the same direction, the speed and velocity are the same thing. So the velocity is given by the gradient of the distance time graph. The speed or velocity is given by the gradient of the, I'm going to write it here, the gradient of the distance time graph gives the speed of the object. The gradient of the distance time graph gives the speed of the object. So in this scenario, in the first part, I'll call this A, I'll call this B. You see that there are two different shapes. This is an increasing shape and this is a decreasing shape. And I'll call this part E. So when you see in the part A, if it started from rest, the gradient is constant. That means that the object is moving with a constant speed. Part A is that object is moving with a constant speed because the gradient is constant. So the object is moving with a constant speed. There is a constant change in distance per unit time, right? Rate of change of distance is constant. So part A, the object is moving with a constant speed. And why it is moving with a constant speed? Because the rate of change of distance is constant. The gradient is constant. The gradient at this part is constant. The gradient is a uniform constant gradient. Is positive constant. Right? So object is moving with a constant speed. Let's talk about part B now. What is happening at part B? The object is at rest. You see why? Let's just have 5, 10, I'll call this 15, 20, 25, and so on. Let's say this is, right? So let's say this is 30 and 35. Okay. So just have a look at the shape of the graph at 15 meters. You see, as the time is increasing, the distance is not changing. The distance is the same. You see, the distance is not changing. As the time is increasing, the distance is not changing. So this tells us that the object is at rest. So the gradient is zero here. You can see that the change in y coordinate, that is delta y, is zero. There is no change in the y coordinate. There is no change in the distance. So at part B, what is happening is that the object is at rest. So at part B, the object is at rest. For this distance time graph, the object is at rest. Why? Because the gradient is zero. The gradient is zero. Gradient is also known as the slope of the graph. You see that there is no change in the y coordinate. The change in distance is zero, right? So that's why the object is at rest. As the time is increasing, the distance is not changing. Let's talk about part C. What is happening at part C? You see, there is an increase in the gradient. You see what's happening? I'm gonna show you with different colors here. So I'm gonna draw a tangent. A tangent is a gradient which touches at only one point. So this is touching at when only one point, you see the gradient is increasing. There is an increase in the gradient. There is an increase in the gradient, right? When there is an increase in the gradient, this means that the speed is increasing. Although the distance is increasing, but it is increasing with an increasing rate. The distance is increasing with an increasing rate. So the speed is increasing. So at part C, the speed of the object is increasing. Part C, the object is moving with an increasing speed. Although the distance is increasing, the object is moving with an increasing speed. Since it is moving in the same direction, you can also say here, only for this graph, that it is moving with an increasing velocity because the object is moving towards a specific direction. And you can say that as well. So object is moving with an increasing speed here, right? The object is moving with an increasing speed. And why is that? Because the gradient is increasing. The gradient is increasing. Remember that the gradient of the distance time graph gives the speed of the object. This will help you a lot. For part D, now I hope you will be pretty much familiar now what's happening at part D. You see at part D, the gradient is decreasing. You see it is decreasing. It is not negative, but it is decreasing. It is moving towards zero. It is moving towards zero. You see it's flattening out. So the gradient is decreasing. So when the gradient of a distance time graph decreases, what happens? Its speed decreases. So let me part D, the gradient, the speed of the object is decreasing. It is not negative, remember that. The speed of the object is decreasing. Decreasing, right? The speed of the object is decreasing. Why? Because the gradient is decreasing. But this is not negative. The gradient is decreasing. And one more important thing that you can see here is that although the speed is decreasing, the distance is increasing. You see, the distance is still increasing. It's moving above 25 and then 30 and so on. So the distance is increasing, but the speed is decreasing. And what happens at part E? The graph flattens out. It flattens out like this. So at this point, the object is at rest. So this part is rest. So object is at rest again. So E is the object is at for. So one more important thing about this distance time graph is that there are some questions in the O-level physics exam that they ask you to calculate to tell that whether this distance time graph has any acceleration or not. So you can just visualize and you can see here that at this point C, what is happening? Since the speed is increasing, so you know that acceleration is the rate of change of velocity, right? Delta V over delta T. So since it is moving in the same direction, positive direction, the velocity is equivalent to the speed. So since there is a change in speed, the object is accelerating. So at point C, the object is accelerating. And let's talk about point D. What is happening here is that since the gradient is decreasing, the speed is decreasing. And I told you in the previous video as well, and here as well, that when the speed decreases, the object is decelerating or retarding. So in the part D of the graph, from here to here, what is happening? The object is decelerating. So we can deduce from the distance time graph that whether the object is accelerating or decelerating. And this is very important. Decelerating. All right. So let's talk about the speed time graph. And the number one thing that you need to remember is that the gradient of the speed time graph gives the acceleration. The speed time graph gives the acceleration. Because the object is moving in the same direction, so the speed and velocity are the same, and since the rate of change of velocity is acceleration, that's why the gradient of the speed time graph gives the acceleration. You'll come to know more clearly after after a while. So let's have this graph. This is the speed time graph, and let's say this is the speed. The speed is this meters per second, and time in second. It's always good to write the units. It's necessary to write the units along with the notation. For time, I've written s, and for the speed, I've written meter per second. So let's say the object is moving like this. The object is moving like this. Then it is moving like this. After that, it changed its shape like this, and then like this, something of this sort, something is this sort, and then like this. Let me extend this time axis. So this is the time in seconds, and this is the speed in meter per second. So let's talk about part A, then part B, then part C, D, E, F, G, and H. You see that speed is positive, so it is moving in the same direction. So velocity, if the graph would have gone downwards, it would have become a velocity time graph, right? It would have been essentially a velocity time graph if I would have moved downwards. So let's talk about part A. What is happening at part A? The speed is increasing uniformly with time. There is a constant increase in the speed. So the rate of change of speed is constant, right? And obviously the rate of change of velocity is constant. So object is moving with a constant acceleration. The speed is increasing uniformly with time. The object is moving with a constant acceleration. So let's talk about point A. The object is moving with a constant acceleration. You see, this is a constant acceleration. This is not constant acceleration. So in part A, the object is moving with a constant acceleration. This is why, because the gradient is constant. The gradient is constant. It's constant positive. Well, let's see what's happening at part B. In the part B, the object is moving with a constant speed. You see, let's just label this graph 5, 10, 15, 20, 25, 30, 35. Let's say this is 35. You see, the speed is constant. When the speed is constant, what is happening? The acceleration is zero. The acceleration is zero because you see, in part B, the speed is constant, the acceleration is zero. Acceleration is 0 meter per second square, right? And one more mathematical explanation for this is that A is equal to V minus U over delta T. That is also, this delta is the change. So there is no change in the speed or velocity. There is no change in the speed because at this point and at this point, the speed was the same. Let's say this is the time interval delta T. You see, the speed is the same. So this acceleration is 0 over whatever the time interval is, because 15 minus 15 is 0, right? So this is 0 meter per second square. So in this part of the graph, the object is moving with a constant speed and the acceleration is 0 meter per second square. Remember that whenever an object is moving with a constant speed, except in circular motion, it will have zero acceleration, right? But this does not apply to circular motion. We'll discuss this later. Let's talk about part C. So in part C, what is happening is that the object is, the gradient is increasing, the speed is increasing with an increasing rate, and you see the gradient is also increasing. You see the gradient is changing like this. It is increasing, the slope is increasing. So there is a positive change. So the gradient is increasing in part C. So obviously when the gradient is increasing, the acceleration is increasing. This is non-uniform acceleration, and the acceleration is increasing. So velocity is also increasing. Of course, it is increasing with an increasing rate, and the acceleration is also increasing. So at part C, the velocity or the speed is increasing at a non-uniform rate, and the acceleration, because the speed is increasing, the gradient is increasing, the acceleration is also increasing. So and the acceleration is increasing. Acceleration is increasing. All right. What about part D? In part D, what is happening is that the object's speed is increasing but at a decreasing rate, so the acceleration is decreasing. You see the gradient is changing like this. The gradient is turning like this. It is becoming less steep. It is becoming less steep. You see, it is becoming less steep. So since the gradient is decreasing, the acceleration is decreasing. You remember my lecture on non-uniform acceleration. So this is non-uniform acceleration but with a decreasing acceleration. So I'm gonna write it here. Part D, the object is, the speed of the object is increasing at a non-uniform rate. The speed, you see the speed is not decreasing here, it is increasing. The speed of the object is increasing, but the acceleration is decreasing. Acceleration is decreasing. This is another example of non-uniform acceleration. The gradient is decreasing. For the E part, again, the object is moving with a constant speed. So it is pretty much similar. It's almost the same as B, because the explanation will go the same for E as well. So same as B, that is constant speed. What about F? In F, you see that the gradient is becoming less steeper, right? The gradient is becoming less steeper. For the negative acceleration, it is decreasing negative acceleration. You see, this is decreasing negative acceleration, and this is increasing negative acceleration, right? So these are non-uniform acceleration, but in the negative, they're negative, right? And for the H, it is the constant retardation or constant deceleration, because the gradient is negative, right? For part F, decreasing negative acceleration. The speed is decreasing here, you see? The speed is decreasing, it is becoming less. The speed is decreasing, right? And this is why, because, and this is non-uniform negative acceleration. Non-uniform negative acceleration. Decreasing negative acceleration. And G is increasing negative acceleration. The speed is decreasing at a faster rate. So this is, part G is increasing negative acceleration. And part H, which is constant deceleration or retardation. The negative acceleration is constant. So part H is constant retardation or deceleration. This is very important. Constant retardation or deceleration. The object is decreasing, is having a decrease in its speed, decreasing its speed at a constant rate. Constant rate. So these are the possible shapes that you can expect from a speed time graph. Part A, Part B, Part C, D, E, F and G are less common. H is pretty much common. C and D are common. B is and E are also common, and A is also common, right? But as you see in F and G, what is happening? The gradient is non-constant, right? It is becoming, in F it is becoming less steeper but in the negative direction, and in G it is becoming more steeper in the negative direction.